You all had a thorough training in game theory, so I'm going to say a bit more about the new behavioral insights in game theory, how all kind of empirical findings in game theory deviate from the classical model, especially how all kind of emotions play a role in the play that players do. A good example is by the ultimatum game invented by these people. The game is as follows. A sender receives €100 and can send part of it, X, to a responder. Then the responder can either accept, then the responder gets that X, and the sender has 100 minus X. But the responder can also reject, then both get 0. So very simple game. Now first we analyze it in a classical manner, assuming Homo economicus, that you've been learning in many courses probably already. And I assume you all know, so I immediately say how it goes. According to classical theories, the responder will never reject, because 0 is the lowest he can get, she can get. So nothing, might as well always accept. Accept is always at least as much. Well, the sender knows it, so acceptance is going to be the thing anyhow. Then X is 0 is best for the sender. Then gets maximum amount of money. So this is backward induction, what I was using. And then we get, this is the outcome. The result will be nothing sent and 100, everything stays with the sender. This is the classical solution. But now let us consider this game. What happens with Homo sapiens, with real human beings and in experiments. And the common finding is that real human beings, Homo sapiens, offers of X lower than 10 are almost always rejected. So then the sender, the responder apparently think it's so low, I'll have 0 and I think that small amount. The modal offer is 50 even. Apparently senders seem to know that they should send something good, otherwise it's not it might be rejected, or maybe they don't care, they want to send something good anyhow, they're altruistic. All those kind of emotions are going on. So the modal outcome is that 50 is being sent and then being accepted. Both have an equal share, 50-50. So people are driven in reality. Also, these games have been done very well, completely anonymous. A player in Holland playing against a player in Russia, and they never know who it is, they will never meet. So still, these kind of things are found. Still, people are driven really by fairness and altruism regarding preferences. So these empirical findings are again very different from what the classical models say, and we'll have to bring in much more of emotion and psychology to understand what human beings are doing. Another game illustrating similarly is the trust game. It goes as follows. Again, there's a sender and a responder, but let's read slowly how the explanation is written. So first of all, again, the sender receives 100. Again, part of it, X, can be sent to the responder, and the rest is already for the sender to keep. But now the difference from the ultimatum game is the money amount sent to the responder is multiplied by 3 by the experimentals. So the responder gets more money, gets 3x, not x. Then it goes the same way. The responder can decide how much of the money received is given back to the sender, keeping the rest. And that's the game. And what will happen for Homo economicus? Maybe you can pause the video a moment and think for yourself. But I guess you can quite quickly understand once the responder has received X, whatever it is, responded, but just whatever he sends back, so she sends back, is lost. So for her, so the responder will send nothing back. Then the sender knows nothing is going to be sent back anyhow. Whatever I send to the responder is a loss. So the sender will send nothing. So here, classical theory, backward induction effect, says the outcome will be the same as in the ultimatum game. Nothing is sent, then of course nothing sent back. 100, 0 being the final outcome. Now we look at Homo sapiens and experiments. Many experiments have been done. What happens there? Well, the modal sending is 50. So half of the money the sender will send. Again, like before. And the modal response, how much the responder sends back, is also 50. So that means the outcome then is 100. Notice the sender sent 50, but got 50 back, stays at 100. And the responder received 150, about 50 multiplied by 3 became 150, sent back 50, 100 results. This is the model outcome. Quite nice for both of them. By the way, it looks a bit like the responders want to be, the sender should not lose from what they did, but not gain either. That's a kind of emotion going on here. But anyway, again, this is very different from classical. All kind of emotions have been studied, all kind of variations of the game to investigate whether it's altruism or fairness or all these things. Move many studies in detail into this. By the way, another question, if these players could perfectly well cooperate and coordinate all their action and trust each other, what would they do then? Coase theorem would apply. I don't know if Coase theorem is still treated with game theory, if you ever heard of it, but in that spirit. Anyway, if the players can completely cooperate and trust each other, well, maybe you can pause the video, think a moment. But what will happen is that 100 will be sent, because then that is the biggest amount that is multiplied by 3, it becomes 300. And then after that, how they divide the 300, maybe they do equally 150 for both or whatever. But surely, perfect cooperation, if they do what's best for the group as a whole, 100 will be sent. In reality, not that, but only 50 in the model sense. Now we go to another game by these people. It's a bit of a complex game, and we'll only look at non-random choices, and there will be some equilibrium. The randomization does bring more equilibrium. So in that sense, it's not a big problem that we only look for simplicity of non-random choices. I recommend that you pause the video now and spend maybe a few minutes to study the game, to think what happens and what classical theories say, what would you do, answer these questions, and after that you come back and listen again to what I say. So then I will continue on analyzing the game. For Homo economicus, the classical approach, we can see that there are, well, you already did the thinking, we can see there are two Nash equilibria. Top left is equilibrium, so that's here. Then nobody benefits from deviating. Bottom right is also equilibrium. Then again, nobody benefits from deviating. So two equilibrium. There are no other ones. Also, if you want to do randomization. But then I ask you also to think about what would you do if you were to play the game. I don't know how you think about it. I know what I think. But playing any of the real equilibria is really risky, especially for the green, the column player. And the more so because there are two equilibria. And if they coordinate on the wrong equilibrium, it's horrible. Like if the column player thinks, oh, we'll go for this equilibrium, but unfortunately the row player thought the other equilibrium is playing bottom, the column player is suffering horribly. Same thing here. If the column player thinks we're going for this equilibrium, but the row player went for the other, the column player, the green player, suffers horribly. Very few people, also me, would not want to risk any of that. If you see the other, so left and right are dangerous strategies. C is also quite dangerous, because you don't know, this guy may just will be to his bottom, not so very clear. So then here there's also a risk for -100. This and the no Nash strategy, because it's not part of any Nash equilibrium, but that looks quite good. Then you just get 30 for sure, and no risk. It's not a Nash equilibrium, but not part of it. But still, if I were a column player, I would play NN, I think. I guess many of you would do so also. That classical theory cannot accommodate this. Well, experiments were done with Homo sapiens, real subjects, and these are the things found. And as you see, indeed, the column player, the great majority, does play NN, which makes sense. But again, it's not classical theory. Then the row player, the majority, plays the top Maybe this 200 is quite attractive. I hope for it still. And other than that, it doesn't matter so very much. So this is the common finding. Now, if I teach this in class, then once in every 3 years, there will be a clever student who says, hey, professor, the percentages for the column don't add up to 100. They add up to 102. There's something wrong there. And that's true. And I took these numbers from the paper, so the paper must have made some typo or something, but nothing. I think essentially the results are as written here, so it's not a big problem. But again, here you see also in such games, many things happening, many kind of emotions, different class, all kind of risk attitudes and certainty play a role that classical theories cannot accommodate. Well, let me end this chapter and immediately go on with the summary of the ordinal principles that we are going to deviate from a bit. So 2 principles I want to reiterate. One is the revealed preference paradigm, that everything should be based on choice-based inputs, choice making. And the second, that they assume rationality. For a long time, people, also economists, classical economists, everybody knew that human beings are doing many irrationalities. But the common thinking was irrationalities are so chaotic and unpredictable, we cannot make theory of it. So the best approximation of, here's a citation of Arrow, let's not read it now, or at least you can read it yourself, pause the video. But they thought, long time people thought, the best approximation of real behavior that we can get is rational behavior, also for empirical purposes. And then the big novelty, Kahneman and Tversky were the first to really do it. The behavioral approach was that also for irrational behavior, there's enough system in it that we can model it. That was a surprising discovery. That was the beginning of the behavioral approach. In this course, there's Newton. He also had a citation that's in the spirit of what Arrow said. Newton said, I can calculate the motion of heavenly bodies, but not the madness of people. So he also said something like irrationality, you can't analyze it. But now the behavioral approach is doing what Arrow and Newton thought to be impossible. Well, in this course, we will look at we will mostly be looking at the second point, relaxing this rationality assumption, bring in emotions. We will do very little. Most of what we do will still be choice-based, will be within the revealed preference paradigm. Also, there's quite something going on in the behavioral approach where the revealed preference paradigm is relaxed. We'll say a few things about that at the end, but not much. You can't do everything. So that's what will come in the rest of the course. Now we're going to turn to the first beginning of behavioral approach, chapter 3. That will be in the next recording. So I'm stopping now.